We're continuing with Chapter 1 in the algebra textbook. In this video, we're going to go through the 6th section, which you can see it's titled More Equations and Applications. And so, but what we're going to be talking about is polynomial equations, absolute value equations, and radical equations. Now, we're also going to look at the end of the section, the idea of being able to look at an equation and identify that if we can make a substitution for some variable or an expression, then we can put that equation into a form that we're familiar with, like the form of a quadratic equation or linear equation, etc. And so that'll be interesting as well. Okay, so a polynomial equation, it's very simple. So we know that a linear equation in any number of variables and a quadratic equation in any number of variables those are polynomial equations. Okay, so we know a polynomial equation is an equation to where every single term or expression on both sides of the equality is polynomial in one or multiple variables. So a polynomial term is something like, right? It's where each variable is raised to a whole number exponent. So that's positive integers, but also 0, which would be just like a constant. This would be, just 3. Okay, so every single one of these variables is raised to a positive integer exponent. Now, this term as a whole, we say that the degree of this term is 3 plus 1 plus 1 is 5. This is degree 5. And so you can do, whatever. So x, z to the 5th is equal to 7x, right? So every single one of these terms is polynomial. So this is a polynomial equation. This has degree 6. This has degree 1. This is linear here. This is linear. This would be quadratic because the degree is 2. Okay, and so all a polynomial expression is going to be, when you say polynomial expression or polynomial equation, it's just going to be a polynomial equation or expression with degree 3 or higher. Even though when the degree is 2 or lower, that's still polynomial. We call degree 2 or lower quadratic, and we call degree 1 or lower, I guess, with constants, we call that, but even this could have a constant in it. We call that linear. But everything degree 3 and above we just call polynomial. That's the idea. Okay, so now, how do we solve polynomial equations? And we're going to focus on in one variable, but as I've mentioned, you could extend these same concepts to multiple variables, because at the end of the day, you're still just like solving for, even when you're solving an equation in multiple variables, it's like you're solving for one variable, and then you're kind of treating the other variables as constants. So, but to study this, we're gonna solve polynomial equations in one variable. All we're gonna do is we use the same method that we use to solve quadratic equations, the first method, the zero product property method. That's it. So you expand everything out, combine like terms, bring everything to one side with 0 on the other side, and then fully factor the polynomial expression, and then set all the factors equal to 0. That's how that's the process you're going to use to solve a polynomial in any polynomial equation. And now you might be thinking, well, what if we can't factor it? Like, there were certain situations in pre-algebra where we weren't able to factor the polynomial. Well, all the polynomial equations we're going to work in this section, we're going to be able to factor it. However, you're going to see, once we get to chapter 3, we're going to learn some much more powerful techniques that will allow us to factor any polynomial. So don't worry about that. All right, so let's start with, here's this polynomial equation, and you can think about how it was, it might not start off with everything expanded out and combined and all the terms on one side, right? You might have to put it into that form. And then you get into this form and you see, you call this polynomial just because the degree is 3 or higher. If the degree was 2 or lower than, if we just had this, we'd call that quadratic, even though that technically is polynomial. And same here. If we had this, we'd call that linear, even though technically that is polynomial as well. Like you can solve a quadratic or even a linear equation using the zero product property method. Right here, we could, if we had this linear equation here, okay, well, let's factor out a 9. 9 times 3 is 27. There you go. X is equal to 3, right? Okay. So, but how do we factor when we have a four-term expression, four-term polynomial expression, how do we factor it? Well, the default method is to look for grouping. So this looks like it's already grouped the way we want it to be grouped, with the 9 and 27 together and the 4 and the 12. So here, these first two terms, let's take out a 4x squared. So we've got x plus 3. And then here, let's take out a minus 9. And we've got x plus 3. And yeah, I mean, you might wonder, well, it's so convenient that the grouping worked, right? It's so convenient. But in reality, the grouping, you'll try grouping and it won't work. Again, when we get to chapter 3, you'll see how even if none of the methods that we learned in pre-algebra for factoring worked, we're going to learn some significantly more powerful methods for factoring in chapter 3. So you'll be able to factor anything, any polynomial. Okay, so we've got 4x squared minus 9, and then x plus 3, and there you go. Now we've got well, no, actually we're not done, because we can write this as, let's see, this is 2x squared minus 3 squared, so 2x squared minus 3 squared, so we can write this as 2x plus 3 times 2x minus 3 times x plus 3 is equal to 0. So that's fully factored. And so you can see we're going to get x is equal to 3 halves minus 3 halves and minus 3. Okay? All right. Now this next problem, we've got 2x to the 5th is equal to 16x squared. So you look at this and you think, okay, well, let's divide by 2x squared, both sides. And you get what? X cubed is equal to 8. Take the cube root of both sides. You get x is equal to 2. We didn't do anything wrong here. That was all mathematically completely valid. And x is equal to 2 is absolutely a solution. I mean, okay, 2 to the 5th is 32. 32 times 2 is 64. 2 squared is 4. 16 times 4 is 64. That is a solution. However, because we divided both sides by an x term, this is one of the cases that we've talked about where we have to come back and see, okay, well, wait a minute. This mathematical operation we did, we can multiply 0 by both sides of an equation, and that's mathematically valid. Even though it doesn't result in an equivalent equation, it's still not incorrect mathematically. Here, we couldn't proceed forward if x was 0. So you kind of look at it in this case like, well, okay, we kind of eliminated 0 as a potential answer, so we need to check 0, and you can see 0 is a solution. So that's why the more standard procedure for solving a polynomial equation is you just put everything to one side and then factor. And then if you do it that way, then you're not going to be missing any solutions. So now we factor, we've got 2x squared. So x cubed minus 8 is equal to 0. So we're going to get x is equal to 2 when we set this equal to 0. When we set this equal to 0, we're going to get the other solution, x is equal to 0. We can see that is a solution, right? Okay, now here they're talking about rational equations again, and all they're doing here is we're going to another case where we have a rational equation, but when we clear the fractions, the result is a quadratic equation, and that's the idea. Like a rational equation we talked about, it's any equation that has any kind of power x to any kind of whole number power in the denominator. But whenever we learned rational equations a few sections ago, all we had experience with was solving linear equations. So the only rational equations we practiced with were when you clear the fractions, the resulting equation you needed to solve was a linear equation. But now that we know how to solve any kind of polynomial equation, if you think about it, you can have any kind of rational equation, and then after you clear the fractions, you can have any kind of polynomial. The final, which you then have to solve, is any kind of polynomial equation. That could happen with any rational equation. The result is going to be, with a rational equation, the first step you do is you clear the fractions, multiplying by the least common denominator. The result then is going to be some sort of polynomial equation, linear, quadratic, or polynomial. And then what you'll have to do is you'll get your final answer, and then you'll have to check your final answers, even if you didn't make any mistakes, to see if those are actually solutions, or if those are you're dividing by zero. So if we look at this here, so here's an example where we're going to get a quadratic after we clear the fractions. So is equal to x squared minus 2x minus 8, x squared plus 14. So, okay, you've got x minus 4. Okay, you've got x plus 2. And then let's see, this would be x minus 4, x plus 2, and then x squared plus 14. Okay, so now we want to clear the fractions. And so to do this, we want to multiply by x minus 4 times x plus 2. So we have 2x times x plus 2 minus 3 times x minus 4 is equal to x squared plus 14. And you see, so the result we're going to get, now we have to solve a quadratic equation. For all the rational equation problems we worked in section, I think it was 1, the result was always a linear equation because we hadn't learned quadratic or polynomial equations yet. But it could be the case that this ends up being a polynomial equation. So it could be anything. Any kind of polynomial could be the result here. So 2x squared plus 4x minus 3x plus 12 is equal to x squared plus 14. Subtract x squared from both sides. You get this. 4x minus 3x is x. Subtract 14 from both sides, you get this. Okay, so now we've got, let's see, x, 2, 1, we want to do plus 2 minus 1. So x is equal to minus 2 and x is equal to 1, but with rational equations, we need to check the solutions. Minus 2 is not a solution because we're going to be dividing by 0. 1, there's no dividing by 0, so 1 is the only solution here. Okay, so now here's a typical application example that you'll see. Let's take a quick look at this. So Trent takes his boat 6 miles downstream with a 1.5 mile per hour current. The return trip against the current takes 1 hour longer. Find the speed of the boat in still water. Okay, so Trent takes his boat 6 miles downstream with a 1.5 mile per hour current. Okay, the return trip against the current takes 1 hour longer. So, okay, we know that distance is equal to rate times time. That's the main thing we're going to look at here. Okay, so you've got the rate of the boat in still water and the rate of the current. So, but the current is 1.5 miles per hour, so we don't need a variable for that. So he goes, the distance is always going to be 6 because it's 6 miles. The whole trip is 6 miles. So when he's going downstream, okay, 6 is equal to what? We're just going to call this R, the rate in still water. So if he's with the current, then it's R plus 1.5 is the total rate. Okay, and then times the time it takes to, T we can just, is the time to go downstream, 6 miles downstream. We can just leave that as T because it's just going to be one variable because the return trip, it's going to be 6 miles, and then it's going to be his rate, but then against the current, but then the time is going to be 1 hour longer. So t miles per hour, so that the rate is in miles per hour, so we can just leave this in hours. Okay, so we're trying to solve for r. That's what the question is asking. So let's see what we can do. So, okay, let's solve for t in this first equation here. So r plus 1.5 in the denominator, then 6 in the numerator. Okay, now let's see. Let's solve for this t plus 1 here. We've got r minus 1.5. Okay, but now we can solve this for t as well. So we've got then minus 1. And so there we go. So we can set these two t's equal to each other, and we're left with one equation and one unknown. So we've got 6 over r plus 1.5 is equal to then, right? And so there you go. This is going to result in a quadratic equation when we clear this is a rational equation, right? But it's going to be one that results in a quadratic equation once you clear the fractions. And so they solve it and get the r is going to be 4.5 miles an hour. That's the speed of the boat in still water. So we'll work a bunch of examples. You'll get a feel for problems like this. But okay.